Dr. Prashant. And my research interests are groundwater quality, working on Ajmer area. So that was about my profile there and in IGNOU. And here I'll be taking your counseling session. And though as this is my first session, so let's start with what you have read till now. I think can anyone just quickly talk about the topics you have gone through?
Yes, ma'am.
अभी तक is it okay if I continue in English or Hindi or both the languages? What way you people are comfortable?
Ma'am, both.
Both.
Both language.
ठीक है तो आप ठीक है आपने इंग्लिश सॉरी इंग्लिश हिंदी वाला बात हो गया अभी आपने क्विकली क्या क्या टॉपिक्स यू हैव गॉन थ्रू क्विकली जस्ट यू नेम देम सो दैट आई गेट एन आइडिया कि आपका अंडरस्टैंडिंग लेवल क्या है
Ruby, just I would like to intervene here.
हाँ
It is preferred to speak in English here because there are many people from the south who will not be able to understand, and there was some messages in the group also yesterday that it should be preferably it should be English.
Okay. So I'll continue that way, sir. ठीक है. So I hope for this particular paper, I'm supposed to teach today about geographical information system, which is another extension. I mean, after I think you have understood aerial photography, then remote sensing, then basic concepts of digital image processing. Today I'm supposed to take concept of GIS. So GIS stands for Geographical Information System. We know the full form and everything, but do you understand Geographical Information System, its role, how it interacts with the data, and what is the output we expect, and how we get that, and what do we do that with that output? Can we have a small discussion on that? Anybody? What do you understand by GIS, concept of GIS? What idea do you have?
Basically, ma'am, GIS, as we know, the full form of Geographical Information System. When we gather or collect the data from the Earth's surface, that is called a GIS. Basically, in remote sensing, it is totally part of technical session. When we involve with the computer or digitalized data, then GIS is, we can say GIS.
Right. Very well. But before it started with aerial photography and everything, I think you have gone through that portion. After digitization, after the data, the art of collecting data and information that evolved, it got converted into GIS thing, and from there we are taking GIS and various components, various aspect, various data requirement, various kind of processing thing and output. We have broken those things into various subtopics, and we will be taking up those subtopics one by one to understand GIS in a broad way. So let's get started. I'll be sharing my screen with you.
Madam Ruby.
Yes, sir.
In the first session, which I took, giving an overview of geoinformatics, I explained to them that there are three major components of geoinformatics. One is remote sensing, second is geographic information system, GIS, third is global navigation satellite system. So I also told them that it is a remote sensing and the GNSS, which are basically the data acquisition technologies, whereas the GIS is actually data processing platform. So this basic difference I had conveyed to them. Okay, you may please continue.
Okay, sir. So in this particular block,
in between, now please check that there may be some people joining very late, so you may please admit them whenever they join. But we have informed everybody that nobody with a device name will be permitted to enter in the meeting. Only with their names as per the admission database in their application here in the group. They will be permitted. So please look into it also.
Okay.
Thank you.
Okay, sir. Thank you. So as sir gave an overview, like what you have been taught earlier, and from those three important components, remote sensing, GIS and GPS, that means data acquiring, data processing, and then dealing with the output. So we are into a data processing part today, that is GIS. So we will be understanding all the fundamentals related to it. This is your block and it comprises of 3 units. And we will be going through all those units one by one. First of all, I'm directly switching to unit 4, that is your concept of GIS. So what I started just now with GIS, so we are taking that in detail. As we know, GIS is actually GIS is a combination of remote sensing, then digital interpretation, then GPS, and then the combined function of everything leads to a meaningful data there, where we are concerned with GIS and its output through various processes. And what are those processes? We will be dealing with that. First of all, GIS could be broken down into various components. Can anybody name that? Have you undergone that? GIS basically, this is very like one of the most mandatory kind of concept related to GIS, that it has been broken into 5 components like software, hardware, data, people, and GIS technician. Like the combined role of all those components leads to a meaningful output. And we will be taking taking overlook over historical development of GIS, then organizational aspect of GIS. So as we have already seen that GIS stands for a computer system which is used for capturing, storing, managing, querying, analyzing, and displaying geographical data. So GIS is based on different aspects like tool-based, data-based, and organization-based. So what does exactly mean tool-based and then data-based? Let's see that. So GIS starts with a data. Data is the heart of GIS. Whatever you start, you have to deal with the data. Data could be. Can anybody guess what does that mean? Toolbox based. That means for processing a data, we need to have a set of tools which will be responsible for processing the data. So that means it has to be tool based. It includes like powerful set of tools for collecting, storing, retrieving, transforming, and displaying special data from real world. Then comes database. Database means this definition involves a database system in which most of the data are specially indexed. Specially indexed means they have been defined some particular address. Address in what sense we will see in forthcoming time. And upon this data, there is a set of procedure we can operate to answer particular queries or particular meaningful output of that. Then it could be a organization based. Organization based means this kind of a set of automated functions that provide professionals and they provide capability to store, retrieve, manipulate, and display of this particular geospatial data. So this was like GIS could be broken down into various aspects. So what I talked about GIS could be broken into 5 components, that is so first of all, data, then data is processed through a software, through people, and those people, they apply some method and using hardware. Hardware is particularly used for inputting the data. We will see all those components in detail. So in here, I hope my screen is absolutely visible. So first we will go for this computer hardware component, what I mentioned. Hardware means how we can input data. We can input data through digitizer or scanner, disk drive, tape drive, visual or plotter or printer like that. And then we can input data as data could be inputted, like we can, data could be in the form of topo sheets, aerial photographs, imageries, or simply ground truthed data. And after that, data input device could be keyboards, digitizer, mouse, or scanner. And data analysis and transformation, this is main part of GIS, where data is analyzed and transformed logically into spatial data or non-spatial data, or a combination of both. And then the data output comes through monitor, printer, or magnetic media, or simple digital data. So these were the basic components, and when the data we have to store it, retrieve it whenever required, and manage it. So that we can analyze the data, modify the data, transform the data, and combine two different data to get a meaningful output again. So this was component of GIS. It works on a combination of various input devices, output devices, hardware, user, processors, and the data could be a special data or a non-special data. I hope you understand difference between special and non-special data.
Yes, ma'am.
Yes, ma'am.
Okay. So a basic component of GIS, now looking into this third diagram, people component of GIS, a user needs a particular processing of GIS data, then a GIS specialist will make that raw non-conclusive data into some conclusive data, some understandable data, some comprehensive data. So that comes the role of a GIS specialist. Now, taking into historical development, like GIS is what we understand today is one of the most important sciences of things existing today among us. But its development started long back in 1970s. First of all, Canadian Geographical Information System. They started developing it, and they called it CGIS, Canadian Geographical Information System. After that, GIS, that's Geographical Information Retrieval and Analysis System, was developed by US Geological Survey in 1973s. Then it got developed into vector-based software, and it was developed by ISRI. We all are well versed with this particular word, and they are like spread all across the world, headquarter being in US, and they are in India also, everywhere. I mean, we are basically affiliated to ISRI nowadays, and we are using much more content provided by them. Then came free and open sources of GIS softwares like GRASS, Geographical Resource Analysis Supplement System, and again that Open Geospatial Consortium resources. Then India also developed its first GIS system, integrated GIS and image processing software, and it was developed by ISRO SAC, Space Application Center, ISRO. in collaboration with ScanPoint Geomatics in 2009. Then Indian Institute of Technology, Mumbai, they have also developed a low-cost GIS, and they called it Bhugol GIS. So this was overview of historical development of GIS. Then we had been talking about GIS as science and technology. So we will be discussing here about the facilities or the aids GIS has provided us through various its various abilities. So let's have a look into that. Actually, GIS works in two ways. It involves the use of particular class of softwares, associated hardware, tools, digital geographical data, or it helps in technology making involving the advancement of tool capabilities, and we are able to use everything like that. So actually, its GIS is a framework of 4 different components. Like spatial imaging, database management, decision modeling, and design and planning. So what does that mean? Let's see that. Spatial imaging means it provides spatial address through a coordinate system to a data, and so that we can develop it in a, we can see it in a map. Map is defined in terms of latitude and longitude. So GIS provides a raw data spatial address or spatial imaging. So GIS provides capability to collect, store, analyze, and provide access to data whenever required. So we can manage it through database management system. And decision modeling means it is a GIS capability function with analytical and decision making tool functionalities. That means we can analyze the data, and we can modify the data, and we can modify the data in a way we can make decision on that, or we can make logical conclusion out of that.
Good question, ma'am.
Yes.
On database management, which database generally used in GIS?
Your voice is not that clear. Can you come again?
Which database is used generally in GIS? So Oracle, which one?
Which, okay, there are various, I'm not I cannot tell you right now, but there are many database management system maybe using. I just
Personal geodatabase, file geodatabase, Arc SD, Arc Enterprises, these all are the geodatabase.
Okay.
You know. Okay, thank you.
Okay, thank you. I did not know that. I just knew the process and what are the exact database systems are being used. I did not know that.
Yeah, actually, these all are the database, and first of all, they have introduced personal geodatabase. The size was very limited. Later on, they moved for file geodatabase. They have increased the size, but now in the recent time, all the companies and the organization, they are completely based on the Arc SD. So as we now taking this class through online, so that purpose GIS Arc SD Enterprises. So that is completely remotely we can work together. Suppose we are making one single host in a particular place. From there we can there are 28 states in India. So everywhere we can access the same platform in GIS, and we can work together. So that is the Arc SD Enterprises.
Okay.
Also, the PostGIS there from PostgreSQL, right? That is also mostly used. Okay, thank you.
So there is some actually there is some limitation with personal geodatabase and the file geodatabase. For that reason, they have designed the Arc SD Enterprises. So we can we not need to merge the data. So we have to reconcile daily basis, and it will be automatically merged, and we can see the data from different different types of the users and the location wherever they are sitting. So that reason.
Okay, thank you.
Okay, thank you to you. So, we already discussed on decision modeling. Yes. So decision modeling, it's GIS capability to function with analytical and decision-making tool functionalities. So that we can customize it sometimes also, whatever is our requirement, so we can use tools accordingly. And design and planning, that means it is a function in which GIS tools are used for creation, design, and planning. So we can that's absolutely flexible part of that GIS, an advantage over other geoinformatics system softwares. So organizational aspects, that means GIS, we are talking about advantage of GIS, like it can create awareness. Awareness means that people, basic information of GIS technology is to actually make available people in improving operation, decision-making skill for betterment of organization. So we can actually use that data in a most constructive way. And if we need to do some analysis survey, we can go through GIS for implementing proper system, like provided we have enough background information, we have collected proper data, and we have processed it, so we can do analysis survey, or we can there are many aspects. We have to be careful about institutional issues, like we are able to handle data properly, and there are proper specialists who can handle the data, or we can in fact we can actually use this for education, management, maintenance, and there are like various aspects related to GIS. We can make our people aware, or we can have proper planning. We can have like decision making abilities based on the data analysis. We can merge data and make out something really meaningful. We can proceed with like that. So this was overview of Unit 4. Moving to Unit 5. What I have been provided. See. So Unit 5 deals with GIS data models and spatial data structures. There had been we will be going through raster and vector GIS data models, and we will discuss advantage and disadvantage of raster and data model structures. We will have talk on topology, topological and non-topological data structure and their interaction. So in Unit 5, we are dealing with this. So a data model could be reality. That means we pick from real world. From real world, we make we convert that data into some conceptual model. From that conceptual model data, we can convert it into some logical model data, and then physical model data, where we can have proper interaction among the raw data. So this geospatial data, we can depict the real world data into two basic models, such as object-based model or the field-based model. Can anybody have discussion or just explain what do you understand by object-based model and field-based model? Any idea about that? First of all, a data model represents a set of rules or guidelines which are used to convert the real world feature into digitally and logically represented special objects. A data structure could be between objects, rules which regulate the processing system, everything. So we had been discussing about this. Here the real world could be, it could be object-based model or a field-based model. Object-based model, that means when we do a sampling, we just pick small samples. That means we are concentrating more on particular small features from a total field area, so that we will that could be a sampling location, or we are more interested in picking some objects only, or rather it could be a field based model. That means we are more interested in featuring the whole field. Then from the whole picture, then we are supposed to extract some our interest. So image could be converted into a vector model, image could be converted into a raster model, and both models, vector model and raster model, are interchangeable. And a raster model could be developed from an object-based feature. How we will see that? So that finally our special database is prepared. So basically there are two kinds of models, object-based model or field-based models. So if we will see about raster data model, I hope you understand. If you don't understand, I'll just tell that in a raster based model, we are breaking a particular scene into a combination of rows and column, and that rows and column, the smallest unit of those rows and column, that is a perfect square, that is assigned some number values, and that number value varies from 0 to 255 range, different levels of grayscale, and our data is represented in the form of those pixels, that is small cells, and value of that particular pixel in terms of x and y values gives our, that is address of our that pixel, and the combination of those pixel makes some pictures, or we can modify that our data. So so that layer makes our one set of data. There could be a multiple layers also. And but in vector, we are defining it through three features only. We can represent that data as point value, as through a line, or through a polygon. So when we are representing data in a raster format, we are representing non-continuous data or discrete data. One individual pixel has its own value, a discrete value, a prominent value. When we are talking about vector data, it is kind of representation of continuous data. And that continuous data could be represented, as I mentioned, in the form of line, point line, or polygon. And those, yes.
Ma'am, can you please tell object versus field, the previous slide?
Okay.
Ma'am, I
Object
just
was-
want to know that are you teaching GNSS and GIS from the block 2 fundamentals of GIS?
If it is there, no, GNSS is not there, I think.
Ma'am, there is a confusion.
Yes.
The study material provided to you depicts it as chapter 5, while as given to us it's 6.
This slide contains content of chapter 6 also.
No, the slide you are currently in our study
Fine.
material, it's 6.
So should I move to 6? Because I had been told
That will be a
to
different.
take...
That will be a different subject, ma'am.
So I was supposed to take up
So
unit
let me come
5
in here. Let me come in here. See the content for today's thing. You can see in the schedule. It is for two
Yes, sir,
diploma.
that was I
No,
was
just
talking
just a
about.
minute.
Yeah.
Just a minute. It is for PGCGI, for which the number of units are different. Because in the PGCGI, in the first block, that is on GNSS, there are only 3 units, I think. But in the case of PG Diploma and Master Revised courses, now there are 4, I think, units in the first block. So the content matter for today's session is the block 2, that is relevant to the basics of GIS. So this is what she is taking. That the number of units may be different, but content will be same as it is covered in your block 2. Because this unit number is different for PGCGI and the PGDGI. But you refer to your concerned block, the content should be there.
Sir, I just want to know that under the fundamentals of GIS, it is given in the schedule that GNSS and GIS. Okay, so ma'am is teaching in that only.
Your course title is GNSS and GIS, and the first block was taken yesterday by Madam Akli Gogoi, and this is today. It is the second block that is being covered. Okay, so in that course, MGY 003 or MGY 103, it is the third course of your first semester, and it contains the subject matter of GNSS and GIS. So GNSS is covered in the first block, whereas the remaining 3 blocks uh, are covering the content matter for GIS. So this is
Okay,
the
thank you, sir.
second block. It is the
It's
same
very-
course, same course.
Yes, thank you, sir.
Okay, so sir, I assume this is common portion covered in both courses.
Yes, yes, yes.
Okay. Okay.
There could be slight variation, but they need not worry about it. There will be slight variation.
Okay. So let's pick from where we left. I was talking about object-based model and field-based model. So that means object-based model, we are supposed to pick a particular portion from the field and the whole field is not of our interest or not beneficial to us. Then we will pick small object. That means like we are going and doing sampling. Sampling means if I being from water quality, I being from like water quality, I'm working with in that particular field. So I'll just go and pick small object of my interest. I'll just pick water samples. If I'm doing some sampling for some like rock sample, I'll go and pick those small samples only. Then I'll come and process my data for those small objects. That is small based model. Or field based model, that means I will capture the whole field and then bring it to my lab, that data, and process on my system. Am I clear now?
Ma'am, what do you mean by whole field? Like, I didn't get the context.
Whole field, that means I'll capture the whole scene.
Okay, so sampling models.
From there, I'll extract my interest. I'll process the data. If I need to show some point object, like in a particular field, there are, say, for example, plant of particular species. So I'll just pinpoint those plants and I'll tell this is my field-based model. And from that field-based model, I'll show my samples placed over that. But in object-based model, I'll just pick my one area of interest, or what do you call that, training site. I'll just pick that, and I'll from the whole field, I'll just pick those those points of my interest, data about those points only.
Okay, ma'am. Thank you.
So when you will be reading that application part, then it will be clear, like it's based on application in various fields.
So basically it depends on the application part. These both.
Right. This is actually my approach depending on my requirement.
Okay.
So when as it is mentioned in the flow chart, is it like the object recognition and interpretation? So that field-based model is moving towards this vector model, and but so they can be aligned both ways, no? Like vector also,
Yes,
raster also.
yes. That's the part of processing comes.
Okay, okay.
So we have gone through like how do we represent raster and how do we represent vector, and like in vector a point is assigned a xy value. Like you go and you can just tell that this particular particular hospital, like it's mentioned here, it lies in this latitude longitude, so we can just pinpoint that, or just line is created, we can just join those lines, we call that nodes, and we can make a line and polygon, that's a closed polygon. And so we call those point, line, polygon features as feature class. What is your feature class? It's a point feature. What is your feature class? It's a line feature or a closed polygon feature. So those class feature, like we will say those, like if my requirement is I cannot trace I cannot draw a road using point feature, it has to be a polyline feature. So depending on my requirement, which feature class I'm supposed to opt, that depends on my requirement. So there's a simple comparison between raster and vector. We represent data as pixel or a combination of cell, area of cell, and we provide we assign a particular digital number to that. Same way for vector, we also store is at xy coordinate, we provided xy coordinate, and that storing is quite complex, and we provided actually a coordinate system. This raster data takes a lot of space because each and every pixel has been given a value, and data conversion, it will if we convert from one form to another, it will convert pixel by pixel, so that data becomes quite bulky, whereas vector takes less space and data conversion is fast. Why? Because that makes data sets. The data sets means similar data are clubbed together or read together by the system. So that makes quite easier, or the data becomes lighter. Lighter in the sense easier to process, faster to process. But raster provides a pixel to pixel clarity kind of thing, so analysis becomes simple, and it's very good for smaller analysis, smaller I mean if we are processing smaller data. Whereas vector is most in fact more compatible with complex spatial analysis, or high spatial accuracy is also there. In raster, less spatial accuracy is there. And raster is good for continuous data. Continuous means if there is a water body or a river flowing, then they will have similar kind of pixels. So it becomes easier for representation of continuous data. Whereas in a vector, that point is a discrete entity. And after that, line feature is a discrete entity as shown here. These green dots represent points. That is completely different from line feature. This red lines feature, that data does not mix up. That's a discrete data. Same way polygon, that remains that overlapping of data is not there, or so vector becomes easier for discrete data. So as we discussed that a simple raster data is a grid system which is provided 0, 1, 0, 1 kind of binary data. And like similar kind of pixel could are provided similar values, so that the similar cells becomes, I mean they club together. And there are various data structures for raster data, like cell by cell coding, which is represented in first diagram. Then run length coding, that means similar pixels are clubbed together and read as one value. Then quad tree means that a single data is divided into 4 quadrants, and each quadrant is again divided into 4 quadrants, and that keeps on making rows and column, and they are read as rows. Each quadrant is again divided into 4 half-size quadrant, and alternate individual pixel is reached. So this is the way of reading a data by the system. So kind of data are topological, and we have also seen comparison between raster and vector data. And after that, we are coming into topological or non-topological data. When we are talking about topology or non-topology, we are actually talking about connectivity or non-connectivity of the data. Do you understand the difference? Topological data or non-topological data. Topological data means one data set is connected to another data set spatially. Spatially means one data set, if we move one particular feature, the another feature is related to it, and it will show some related kind of movement in this particular, like if we are stretching a rubber band, an elastic band, the adjoining elastic band will also change its shape. That is the concept of topological data and non-topological data. Like there is a special connectivity. If there is a special connectivity among data, we call it this particular data set is having special relationship, or this particular data set is specially connected. Whereas when we talk about non-topological data set, that means lines or something like that from a particular set of data, we can just pick, or we can remove, or we can add a single data, and the feature of adjoining data will not change, as shown in the diagram. Like if I pick B data from this particular picture, there won't be any change in A or D or E. So this is non-topological data. And wherever like we generally have like it's important to the importance of topological data is in undertaking complex data analysis. And okay, the CAD does not support topology, is it? I did not know that even.
No, ma'am, it supports.
It supports. Yes, it should.
Yes, actually, ma'am, topology, there is like a tool. So with the help of topology, we can rectify our errors as shown in this diagram. A, B, C, D, E. There is a gap between all these polygons. So
Right.
that means when we run the topology, then automatically that gap will be highlighted in the red color. So we can find out the errors, and same as in the line and the point also. So wherever the point will be overlapped with other points, suppose there is a duplicacy, identical, how we can find out the identicals in the line, in the polygon also, in the point also. So for that reason, there is a topology. So that is the basic role of the topology. So topology, it can fix the errors easily. So that is the topology. And
It's kind of
non-topological,
we run topology and that can point out errors.
yes, ma'am. Yes, ma'am.
Uh,
Vector data structure. That's why they have mentioned here topological data structure and non-topological data structure. So topology, suppose once we done any of projects, like suppose we can take the example of the land-based project. There are number of polygons, number of plots are there, some roads are there, even in the duplicacy, how we can identify the duplicacy. So for that reason, we have a topology. So we can run the topology and automatically it will be like highlighted in the different color. So uh, it's easy to find out the errors, and there's some gaps, some pseudo nodes like this.
Right. So the nodes, hanging nodes, we can rectify that after running topology.
Yes, ma'am. Yes, ma'am. Gaps.
Mhm. So, shapefile is a standard non-topological data format used in GIS. Shapefile is non-topological data. Okay, because that is discrete data. Right.
Yes, ma'am. Actually, shapefile that is not coming under topology. For that, for run the topology, we need to make the feature class in any of the uh, data set inside
Right.
the. Suppose in the previous slides we have talk about the file geodatabase and the personal geodatabase. That is the file geodatabase. Inside there is many of different type of data sets. Suppose the water body is the data set. So there are different types of water bodies. So suppose water body, road data set is a different. So save file is a single save file. So we cannot run the topology in directly on the save file. For that save file, we need to convert in the feature class. Then after we can run the topology with a particular data set.
Okay, we have to convert that shapefile into feature class.
Feature class, ma'am. Yes, ma'am.
Okay, okay.
Feature layer, that we can say feature layer.
Okay. Then we have to run topology.
Yes, ma'am.
Okay, okay.
Because topology automatically stored in a single data set. Inside the file geodatabase, there will be different type of data sets. Suppose I need to run the topology on the road data set. In India, in particular state, there are number of roads. Then we have to find out identical. Then for particular data set, I can run the topology, and for the different one, different data set like
Okay.
land base, other data. So different data set for different topology.
I hope others are able to follow this discussion.
Ma'am, how the submerged surfaces topology is defined?
Submerged data topology is submerged data means what? What do you
Like ma'am, Mr. Kamal, he addressed water surfaces, vegetation, and everything. Like if we have to draw a topology of a submerged for if we say that Ram Setu, for example, that surface there and it is below like 100 meters or 50 meters below the water surface. So then how we will do that?
For that, I think
Actually, the topology purpose, I already spoke about why we need the topology. Topology, there is a specific tool. As we had a chat in the previous classes also, the toolbox is there. Like topology, a different type of.
Okay. Just let me come
Yeah.
in here. Let me just come in here. See, topology is a concept. Okay, not to get confused with topography. Topography is something different. Topology, we're talking here about topology. Topology is a concept that is very much important. Unless your data, the features that you have digitized, the picture which you have in your file, if the topology is not built into that, then you will not be able to run the process properly. It will not give you a correct output. So
Correct.
topology is a concept in which
For
just
the verification of the data, right?
एक आपने जो है एक एक्सरसाइज किया है ना, you did one exercise in that you digitized some polygons. Okay,
right, sir. Right,
so probably most of you did not digitize the polygons which share some common boundary. Okay, probably you digitize some polygons which were located at different places. So if you have a file that contains number of features, number of polygons, and those polygons should contain a common boundary. So to contain a common boundary, it needs the topology is to be built. Okay, so two different polygons, two adjacent polygons will share the same boundary if you build the topology. So topology is not a tool, it is a concept, and that concept is introduced through running some options in your software. It is not a tool, it is a concept that has to be, the topology has to be built. Okay, so it basically constrained how the different features in your data share the geometry. Okay, so this is the basic example. So it refers to the geometry. Okay.
So, but like in
How
general, I'm asking like if we have to how जैसे सर normally तो किसी भी surface का जो water level के above है उसको तो आप capture कर सकते हो satellites के through या जो भी अपने पास vision है. But अगर
हम्म,
underwater करना है तो कैसे करेंगे सर? In general, I'm asking if you can tell.
अगर अगर आपका फीचर्स दिख रहा है इमेज में या फिर जिस डेटा में है, तो अगर वहां से दिखता है तो आप मैप कर लेंगे. ठीक है, एडम्स ब्रिज की बात की आपने, दैट कैन बी मैप्ड. देयर इज अ सरफेस एक्सप्रेशन ऑफ दैट आल्सो, सो इट कैन बी
जैसे
Sonography
सर
is there.
नॉर्मली तो किसी भी जैसे कोई प्लांट है या पानी है उसका एक स्पेक्ट्रल सिग्नेचर होता है, रिफ्लेक्टेंस है. अब कोई वाटर के अंदर है तो उसका कैसे आप उसका तो रिफ्लेक्टेंस कैसे निकालोगे सर? कैलकुलेट कैसे होगा वो?
वो वो उसका भी आएगा, बट दैट विल नॉट बी a correct reflectance, because that will be modified significantly by the presence of water
प्रोसेसिंग करना
column.
मतलब प्री प्रोसेसिंग और वो पोस्ट प्रोसेसिंग करके करना पड़ेगा सर, राइट?
नहीं नहीं, वो आप कितना भी कर लो, बट इट इज डिफिकल्ट टू रिमूव द इफेक्ट ऑफ वाटर कॉलम ऑन दैट फीचर्स. I'll just give you example.
जी सर.
Say if there is a seagrass, there's a seagrass at the at 3 meter depth, and if
जी
there
सर.
is a sand at 20 meter depth, even 10 meter depth. Okay, so
जी
these
सर.
two are distinct objects, but they give similar, they give same reflectance. This we faced when I was mapping the coral reefs of Lakshadweep and Andaman Nicobar. I
अंडमान
found this
अंडमान.
problem.
जी सर.
So then it cannot be done. It cannot be missed. There are processes through which we can remove to some extent the effect of water column, but it is not totally foolproof. So you have to do some corrections after you are mapping. So what we did was, in our case, we mapped them. We did the supervised classification. We mapped them separate. It was coming as a sand only. Okay, but then we knew that sand will not occur at that particular depth. It will occur only at certain locations, because sand, if there is a sand, it means that there is a deposition. Okay, so and seagrass will not found beyond the reef edges, and that will continue only in the lagoon part. So there was this confusion, and then we found out that we can it
मतलब
is
सर वो
not.
एकदम लोकेशन स्पेसिफिक हो गया कि जिस
Yeah,
हिसाब से.
yeah. So every habitat, every material will be determined by in this particular case, it is the coastal processes that will determine which kind of material can be formed. Okay. So let us now come back to our this discussion. The topology is basically a concept, and in that it refers to the geometry of the features. So the topology is to be built in the, if you just digitize various features, you just see the example in the figure, that the slide that madam is showing. So you see
Okay.
that A, B, C, D, E. If you start digitizing, I have seen some people who digitize the common area. Again, they digitize the same line, but it is not the way to do digitize those features. Okay, it is much easy to digitize the features, polygons which are separately at some distance. But if they share some boundary, the boundary has to be common in that. Okay, otherwise it will all appear as a different islands, not as a
Yes sir.
as a. So topology has to be built in. Thank
Okay
you.
sir. Thank you sir. Thank you so much.
So I hope this concept of non-topological and topological data is clear, and how one data is connected to adjoining data and what is like how they interact. And we have to be like, if they share a common boundary, we have to be deal it differently. So after that, I am moving to your unit 6, that is non-spatial data structure. Non-spatial data structure, that means we are moving to we will be defining a non-spatial data, then we will differentiate between data and information, then we will describe types of data and models of databases, then we have discussion on geographical data, geographical information, and how we do queries. So let's see. First of all, data. Data is actually defined as body of facts or figure which we gather systematically, and which are obviously of our interest. And information is about the data, and we can like make some information really meaningful, or that information is about the data. So in a GIS system, we actually convert data into information, and that information is about the data. So we try to generate information about data. And how do we do that? First of all, we need to understand a database. Database is defined as automated, formally defined, or centrally controlled collection of persistent data used and shared by different users in an enterprise. This is formal definition. Now let's understand types of data. Data could be special or non-special. Special means it could be specially defined. That means in space it has got some address in terms of location, address in like we can define its shape, size, orientation, features, and interaction of features. All could be defined, and this here they have given the example like 3 stumps in a cricket ground which have a special relation. That means you can define position or location of one data in relation to another data. That means relative information could be explained. The shape could be explained. The size could be explained in relation to another. So relatively, we can define those data. So that we will call that special data. Now for non-special data, we call it attribute data, or that characteristic of that data. That means a particular, like my name is this, my age is this, I study in this class, I'm pursuing this, this is my height. So all my characteristic could be explained as my attribute, or that is my characteristic. So the example given here, that means I have labeled it 1 to 3 in my data, but actually that is river 2, its length is this much, or it has got this much damp, or the water depth is this, and all the special feature and various characteristics of those special feature are actually its attribute data. And attribute data, non-spatial data, from a map we can convert it into a combination of rows and column in which special features, they could be they become very much easier to handle, and they become very comprehensive and very much simple, so that all the complex map features are converted into simpler tabular form, where we can read the data, we can correlate the data, we can establish a correlation between it. So geographical data are actually geographically referenced, where we can locate, we can identify the feature, and they are made up of descriptive elements. That means we can describe it, this is its length, its coordinates, and everything we can define. So descriptive description of each and every feature becomes possible. And those geographical elements, we call it geographical data, special data, and attributes about those special data is actually then the data becomes really meaningful when we can define it specially and its attributes are mentioned. So this GIS emphasis use of special dimension for turning data, actually raw data is converted into meaningful information, and thus we can just understand our geographical phenomena, or our data becomes meaningful. There are few models defined in like database, and the whatever our input, it could be stored in a different through different datas, and data could be, just 1 second, my battery is running low.
Those of you who have not yet mark your attendance, you can mark it now.
Yeah, okay.
There seems to be some issue
Are
with
we,
counselors.
sir, are we going to have any hands-on in the center, or there will be directly an exam? Any practice session or something?
This is what you are running in the online mode right now.
This is only for 1 month. The exams are going to be held in June, so
But recordings are available. You can watch them and then you can practice with that. If you want to come to the study center, but then you have to find if the counselor is available on the day that you are going to come. Or maybe you can find out with
right.
them if somebody is available, then you can come there.
And we can submit our assignments anytime, which are already, given to us, the assignment for the first
जो आप
semester.
जो इग्नू ने टाइमलाइन दी है आपको आपको उसी के टाइम के डेट के अंदर में आपको असाइनमेंट सबमिट करना होगा
The timeline तो कहीं mentioned नहीं है. There's nowhere the timeline is mentioned. The mentioned part was September in the assignment page itself. So September is already gone. We got the assignment late. So I don't know what is
नहीं आपने
the date.
असाइनमेंट देखा है बट आई थिंक यू हैव मिस टू सी द रिसेंट नोटिफिकेशन रिगार्डिंग द सबमिशन ऑफ असाइनमेंट्स तो आप एक बार चेक कर लीजिए वेबसाइट पे जो असाइनमेंट में
Okay.
मेंशन किया होगा उसमें ये लिखा होगा कि जनरली इट इज द डेट फॉर सबमिशन ऑफ द असाइनमेंट but
Yeah,
there could
right.
be some changes in the date depending upon the university's guidelines. So you please check the university website ignu.ac.in for the latest updates with regard to dates for submission of assignments.
Sir, I think it was mentioned during previous classes, 31st March would be the date. But please correct me if I am wrong. That was mentioned, 31st March, we have to submit.
So
But that was
anytime before that date we can submit, isn't it?
That is the last
Yeah,
date.
yes, that was being discussed in the group on WhatsApp.
वो देखिए यहाँ पे 3 प्रोग्राम के लोग हैं, PGCGI, PGDGI और MSCGI.
MSc. हाँ जी.
PGCGI के लिए it is only 1 semester program. So whenever they want to submit, they want to appear in the theory exam, practical exam, they have to fill the exam form. And when you fill the exam form, there is a question that comes whether you have submitted your assignments. So you can check yes only when you have submitted your assignment. So assignment date का submission जो है वो जो due date है university का उसके अंदर ही करना पड़ेगा. So those of you who are appealing for the examination for December term and examination, for them the last date was the one which was given by the university. Okay, उनके लिए था. अभी for MSc it is also for the diploma. उनके जो first semester का exam है वो दिसंबर में होगा, जिन्होंने जुलाई में जिन्होंने एडमिशन लिया. But those of you who are from MSc GI program, your first examination will be held in the month of June next year. It will be June 24 term and examination. So for that you can, for June term and examination, generally the last date for submission of assignment is March, and for December term and examination the submission of last date for assignments is September. Okay, there could be some change. For that change in the dates, you have to see the latest updates in the university websites.
So we'll have to submit term 1, term 2, both the assignments by 31st March then, because it was mentioned that June we'll have both the term exams for MSc.
या सी आपका एग्जाम तो जून में ही होगा, तो आप जो है उस टर्म एंड एग्जामिनेशन के लिए दोनों सेमेस्टर का आप तब तक सबमिट कर सकते हो. पर ये मैंने ये भी कहा था कि जिन लोगों का असाइनमेंट बन चुका है, दे वांट टू सबमिट, यू कांटेक्ट योर स्टडी सेंटर एंड सबमिट इट देयर. So if you have prepared the assignments right now, which is current one, and you submit the same assignment next year, it is not be valid. Why? Because there is a date of validity given in the assignments. So you have to ensure that whichever assignment you are submitting, that has to be valid on the day you are submitting the assignments.
Okay, sir.
Sir, I have a question.
Yes, Sushanta?
Sir, actually, I fill the form of term exam December theory and practical too. I am from PGDGI course, sir. Sir, if sir मैं अगर practical skip कर देता हूँ पहला सेमेस्टर का, तो सेकंड सेमेस्टर में दे सकता हूँ क्या सर प्रैक्टिकल से?
अभी आप थ्योरी एग्जाम देते हैं, प्रैक्टिकल मिस करते हैं तो कोई बात नहीं. नेक्स्ट टाइम जब जून में एग्जाम देना चाहते हैं दोनों का एक साथ, तो देन यू हैव टू अगेन fill the examination for the courses which are remaining. Okay, even if you have filled the exam form this time, you not appeared, it will not be considered. So whenever you want to appear, you have to fill the examination form that time and for those courses that you want to appear in.
मतलब सर दोनों प्रैक्टिकल एक ही सेमेस्टर में दे सकते हैं ना?
आप दे सकते हो, no say restriction on that.
Okay sir, okay, thank you sir, thank you.
Sir, is it mandatory to appear for the practical examination for the particular semester?
It's not mandatory. But you need to complete within the validity of your registration, not beyond that, if you want to successfully complete.
Okay.
But it is advisable that you, whenever you complete your practical, whichever semester you are completing, you prepare your assignment, your practical records, and then you can submit as in consultation with your study center and appear for the examination. Because except for MSc, because if you delay it, if you postpone it for the next semester, you might get busier in the next semester, and then that time might not come. Okay, so we generally see, and with the time, the motivation of the learners reduces. So it is up to you, and that is very important in the audience system. The owners of learning, they say on the